I'm Eric. Thanks for coming. I'm here to show off about the work that we do. We have 3 students with us who've worked on the modules team helping to develop these, and I'll have them come up and talk when we get to the section that they've worked on. My plan is to just walk through some examples, and then happy to field your questions afterwards. What's the motivation for this? We're really interested in finding people to work with. Any different discipline can be enriched by putting data science into their class. We work with humanities, we work with social science, we work with physical science. And any student at UC Berkeley their time here can be enriched by having their hands on data, being literate in the tools that we use. Data science, importantly for us, is not just for computer science or statistics or for information science. It's for everybody. Another part of the pitch that I'm going to give is there's a whole bunch of tools and a whole bunch of infrastructure that's been built for Data 8, this huge undergrad class, and we are offering that to be used for all sorts of other classes at UC Berkeley, and we're also really into for the world. Importantly, the most important tool that we're using here is called Jupyter Notebooks, and we believe strongly that they're a first-class tool for teaching, and we are proselytizing the use of Jupyter Notebooks in all sorts of classes. We'll help you build them, we'll help you deploy them, we want you to touch them and feel them. Outline for the talk. First of all, I'm just going to talk about who we are. There's a little bit of confusion. Who is the Division of Data Science? Next, the pedagogy platform, which is a whole bunch of this infrastructure and tools, and how we want to engage faculty to use these tools. And then I'm going to walk through a set of examples. I think the most interesting thing is just seeing the examples. So the basic level American Cultures class should be adaptable to anybody who's completely data science naive. Just comes in off the street, we'll teach you all that you need to know. There's a lab class, and I think this is a really interesting example for an MCB class. And then for an advanced class where we're going into classification algorithms and text analysis and some, how far along can we get in teaching undergrads, these techniques that are happening now that are like the job skills that people are demanding now. And at the end, I'll do a little bit on interactivity, which is like another part of the teaching that I'm interested in. So the division of data science is we're in a weird moment that we're getting transitioned, but basically you could think about who we are in terms of the classes that we teach. There's a huge class, Data 8. Probably none of you that are not undergrads haven't heard of it, but it's the big, huge class for the undergrads. Right now it's over 1,500 students. It's like 1,600 students are in it this semester, and there's a huge waiting list of people who can't get in it, so sort of like on fire right now. Data 100 is the big gateway upper division class. That's up to 850 students, so that's like the upper div class. That's like a whole bunch of sort of like fundamental techniques in data science. The data science major is launching this year. In May will be the first graduation. 1,000 students pre-registered, probably 250 to 300 will graduate. So that's a big deal for launching a brand new major that didn't exist last year, that potentially up to 300 people are going to graduate in this year. So this is this little map of the major where you start in Data 8, you take a bunch of prereqs, you go through this big gateway class, and then you take a bunch of advanced upper division classes after that. Really big, really popular class. Not enough room to sit down. What's also interesting about this class is that everyone in the class can be computing along with the teacher at the same time. It's a little hard to describe if you don't see it, but if you go in there, and there's this really amazing computer science teacher, John De Niro, who's just sort of like brilliant at doing the live coding. He's also the teacher for CS61A. A lot of the elements of Data 8 came from his experience in teaching the main gateway computer science class. But you can ask him a question and he can just sort of like live code the answer. And then when you're the student, the way this works is you can actually have a copy of the same code on your laptop And you'd be like, I saw him do that. Maybe I'm going to try. He has this like basketball example. He's like, the Warriors, who's got the biggest salary or something? And you're like, oh, I'm going to try a different play. Like there's an amazing pedagogical thing in this class when and if you sit in the back, you can look and see all these different people are like trying something out. So there's some really cool pedagogical thing that happens in this class. There's lots of labs and homeworks. People do them other places. But in terms of the large lecture and making it more interactive and richer, it's really cool to see. Really quickly, a disambiguation about data science at Berkeley. The D Lab is mostly for training and consulting. If you're a graduate student, looks like we have some graduate students here. Lots of awesome seminars. Learn Python, learn Pandas, learn R, learn machine learning. So many great workshops at D Lab. You can also just go for a consulting session. You're working on your dissertation and you're like struggling with something. You go to D Lab, they can help you. That's their business. Fair? Berkeley Institute for Data Science. It's in Doe. It's a place where there's a lot of amazing postdocs working on really cutting edge stuff. It's a beautiful space. They have lots of great workshops. They're also a place where the Jupyter ecosystem is being worked on. So it's also worth going there. You can meet like the actual people who are developing these tools. Who I work for is what is currently called the Data Science Education Program that's focusing on undergrads. We support these big classes, and then we have another part that's trying to support data science in a whole bunch of different other classes. There is something called the Division of Data Sciences that just got created that's currently searching for an associate provost. It was a big news splash in November. Berkeley is starting to dig in and is establishing the Division of Data Science, which is also going to incorporate the School of Information. So right now it's the Division of Data Science and Information. Here's a really weird infographic that you would think was not made by data scientists, with some weird lines spreading around. But anyways, the iSchool is going to become part of it. People from EECS, people from statistics contribute the core faculty. We're going to have this new person who's going to come over the summer, and there's going to be a reorganization. All you need to know down here, Data Science Education Program. So we're working as part of this new organization. Despite this like bureaucratic thing happening over us, our efforts continue throughout. So just a pitch for what we want to do. So this program has a lot of different parts and pieces to it. But we really like to work with people in different domains. We don't see ourselves as like a department that's going to construct our vertical sense of data science. We really like things coming from different classes. People are doing text analysis in a rhetoric class using tools that are, developed over here. People are doing mapping in a sociology class. There's lots of like rich applications and domains. And there's lots of tools that can be applied in different places. And we like working across campus. It's part of our vision is working across campus. And there's sort of like a coalition building. We're looking for professors. We're looking for graduate students who want to engage and work with us. We're not like saying what data science is. We're looking to build data science by having people come into our tent. That's why I'm really glad you're here today. The tool that I'm going to tell you about is called using the Jupyter Hub. Jupyter Hub is a way to deploy Jupyter notebooks. We are going to have labs. We can have things in lecture. We can have homeworks that are all run through this server that UC Berkeley is running called Data Hub, just for a name. It's a way to deploy these computational resources. It's important. I'm giving another talk in 2 weeks that's going to be like more the nuts and bolts of how you run it. And that talk's also going to be about accessibility, which is something we really believe in, right? So it's not, did your dad buy you the great MacBook, right? It's like a Chromebook works, a tablet works, a computer that you borrow works, because it's all in a virtual server. So accessibility is really important. In the world of computation, there's a lot of like, did you have the right package installed? Is it the most recent package? Does your package have a conflict with the operating system? These are age-old problems in statistics, but in lots of different parts of computation. They're also a part of reproducibility in science, right? Can you make sure this runs on all versions? So this is handled by having sort of a central cloud-based deployment. What the students see is a universal, a simplified environment, and they just see it in the browser window. What the students get is like a files on a file server. It's like it's not, students, you know, there's like Dropbox, there's Google Drive, they have their files that are on the Data Hub. There's also a plan, and this is sort of like a gray area, this is in progress. Right now, Division of Data Science is running this project, but there's a vision for ETS and Central Campus to take this over and provide this as a service of UC Berkeley. Right now, we're giving it away free to everybody, but hopefully eventually the campus will take it over and provide it as campus infrastructure. So I'm going to say there's 6 elements in what I call the pedagogy tools or pedagogy platform. The first that we use is Python. Python is a programming language that is a way to teach computational thinking because it reads really nicely. It reads like language. There's a lot of code that you can read, and it looks like a set of words that you could just, you know, put a verb or two in where the periods are, and like it's going to roughly read like syntactically. Within that, there's a ton of packages that are being used, the cutting edge of science, NumPy, Pandas, Matplot, Seaborn. There's, you know, newer and newer versions for data visualization. The second big thing I've already talked about is this thing called Jupyter. Jupyter is a way to package your write-up and your code in the same thing. So you're writing up descriptions of what you're doing in Markdown. You can put LaTeX in there. You can put images in there. And then you have sections of code. And then when you run the code, your visualizations, your outputs are also in there. So you have like what looks like a single document, what looks like a journal article that has the code in the journal article. And it allows you to build these narrative documents that in other parts of science we're really excited for reproducibility. We can like really carefully explain how we did what we did. But for teaching, they just work really, really well for like explaining the steps of what you want a student to do, and then have like an incremental step of what you need to learn with the coding. As I said, Data Hub, this is the UC Berkeley server that we're running that everyone at UC Berkeley has access to. You can go right now, datahub.berkeley.edu, and log on with your Cal ID. So everyone with a UC Berkeley email has the right to log into the server already. Saving you a lot of time, like you don't have to have the specific class list, you don't have to have people specifically registered for a specific server, it's just universally available right now. What we also do is we put the code, if you're a software programmer, you would have heard of this thing, GitHub. It's a very popular place to host software. It just happens to play really well. So I'll explain in the other seminar sort of like how we deploy it. But GitHub is a place that people can share code. So all of the work that we do is hosted on GitHub. You can go to GitHub and find all of the classes that we've developed for UC Berkeley. It's a place where you can browse through all the different notebooks. So all of the work that we do is public. All of the work is shareable. You could look at things and be like, I want to adapt that for my class. Everything that I show you today in the examples, most everything that I show you today in the examples, you can go find on GitHub and just look through it, borrow the code, adapt it for another class.
How do we go to GitHub?
I'll get to it in a little bit, but we are github.com/ds-modules. Finally, there's this little magic touch that you can get. The students never have to see GitHub. All you do is you put a link, a website link on your class website or on your assignment in B courses or however you would be communicating with the students in an email. You basically send them a link, they click on this link, and it just takes them to the browser window with their homework or lab. This is like a really simple thing, but it makes it really beautiful for the students.
Can I ask a question? So, of course, a lot of our students will know about GitHub. What do you do about solutions? Because it would be good to have a set of solutions, but you don't want all the students in the class to have access.
Right, and you don't want them to be permanent because next semester somebody else is going to take the class.
So how do you handle security on solutions on GitHub?
So we usually don't put the solution sets on GitHub, or you can just put them up and take them down.
So you don't have
I mean, it's so you think
area for faculty and
We have private repos. We'll set up a private repo for your class. So in the development sense, we would set up a private repo, and every class would have a public and private. Okay, yes. Yes to private repos for development and for solution sets. And the final element of our pedagogy platform that I want to talk about is these amazing students that work with us, that volunteer for credit, and they build all this awesome stuff for you. All these other things are sort of open source tools. This is just like the totally amazing desire of UC Berkeley students to just like dive in. I would say, as somebody who supervises them, I think it's an amazing opportunity for them. There's this thing on GitHub where it shows green squares the more activity you have. And I think if you're going for a job in 2019, if you have the more green squares you have on your GitHub activity profile, the more the more hireable you would be. But students are doing it for more enriching reasons than that. So just to talk about this all was built for Data 8. Data 8 had this curve of enrollment that was like, crazy logarithmic, right? So it's 100 students, 250 students, 500 students, 1,000 students. Now it's like 1,500 students twice a year, 800 students in the summer. So they built these tools to make space for this class to sort of like logarithmically expand. And it worked, because these tools scaled that way. Outside of just the notebooks, the textbook is open source. It's open licensed. If you're at Yale and Harvard, you can download and use the textbook. You could just use the textbook directly, or you can also download from GitHub the textbook and potentially adapt it. All of the elements used are open source software. So people can comment, people can help document the different elements of everything that's used to teach Data 8. The whole curriculum is open. And we're currently in the process. It's being taught at a high school in Seattle. It's being taught at San Jose Community College. It's being taught at various different universities. So we have a whole team that's involved in other schools using this to teach. And it's about it being an open source project that makes it so adaptable to other universities. It also makes it really useful for other professors at UC Berkeley to use these tools to make awesome curriculum. Right? So there's different projects going in here, but the fact that it's in its core an open source project makes it really useful to us. I will talk about this in a couple weeks, but I'll touch on what it's like to work with us. So you start by thinking up what would you like a notebook to be like? You can sort of create the bare bones. You can create the framework of it. You could also just come to us and be like, here's the homework that I have. Here's my homework in Stata that I used last year. Or here's the homework from R, or here's the homework that people have been doing in paper and pencil. A lot of people have a homework that was in Excel, right? So we can adapt those. We can meet with student teams. The students have different abilities to adapt things. You could also be like, here's a data set that I have an interest in using this data set. What could we do with this data set? So with the professor, we make an account. We make a public and a private account, as the physics professor pointed out, where we can put and work together to put the data sets and the notebooks and anything else together in that sort of public server. Think of this as a Dropbox or a Google Drive or something where we're working together.
When you say notebook, it's like a lecture note, or
it's like a document. It's kind of like a PDF, but you can run code in a PDF is how you need to think about it. It's like PDF because it's gonna be sendable to all sorts of machines. Everybody can read it in this that's using Jupyter, but code runs in it. That's an important distinction. So then we have this little way that we make links. So the students would be like, all right, here, problem set 1's ready, professor. Looks good. Okay, great. Here, let's make a link. Then you're like, I'm going to say assignment 1, students, here's the link for assignment 1. It's due by Friday at 5 p.m. Submit the PDF here. Another way to look at it is how you work with us. So as I said before, you bring your syllabus. We have a meeting with you. You email me. I'll come to your office. We set up a meeting with the students. we generate some students that are interested in this topic. You bring your syllabus, you talk about your learning goals, you bring your existing problem sets, you bring your data set, or you just say, we have this French professor we're working with right now, and he's like, I want to look at gentrification in Paris over the last 100 years with a mapping. And so we're like working with him to find the data set that's going to work for him. He just came with the problem, and he's like, he had come to the summer course, so he knew what it was like, and he was like, I think this would be good in my class, but help me find the data set. We had to find a curriculum developer that spoke French, and we did, so. And then another thing that we do is, we can't promise this all the time, but a lot of times the students that help develop the notebooks come to the class and help teach it. So, and there's a really great like peer-to-peer teaching here, where like, you're teaching the whole year, but the students come in for that one lecture and be like, this is what it's like to use this tool. Or they come to section, which is more like a lab, where like the students are like, all right, we're going to work through lab 1. Oh, I ran into a problem, and the students can, be like the lab instructor while they're working on this notebook-based homework. Important way that we've done this in the past, there's a 3-day summer short course that we teach faculty. Usually it's faculty outside of CS and Stats from humanities, social science, College of Natural Resources, College of Environmental Design. They teach you a little bit of Data 8, so you get into like the ethos of what people are learning in Data 8. There will be panels of instructors who have tried it out, who can show how it's gone. You can actually like start building your notebooks in the summer course. And importantly, on the Thursday is just reserved for like us to meet with you to try and plan out your project. So it's Monday, Tuesday, Wednesday. You're all invited to apply. I do a graduate student one for the graduate students probably on the Friday of that week, which I compress the whole thing into like 3 or 4 hours on a Friday morning. So if you're thinking of teaching a class, this is a great place to come. It's in this room, and you meet other great people. You sign up on the data.berkeley.edu website. One more thing as far as resource goes, if you're the kind of person who just wants to read about how to do all this stuff, we have like an open online book called the Curriculum Guide. You can also go to our website to find it. But this is like most of the documentation, most of the frequently asked questions, a bunch of the details of how to do all this work. And we'll refer to this, like as we're working with you, we'll refer to this. Oh, what if I want a package that they don't have on DataHub? Oh, what if I need to increase the RAM because my data set's so big? Oh, what if I need to, get a special data science classroom? There's a whole bunch of things that can come up that are referenced here, and the workflow's referenced here. So it's growing. If you have anything that you think we should put in there that's not in there, tell us, and we're like constantly adding to it. So thinking about notebooks and how we teach. So there's some sort of important pedagogical starting points to think of. And one is like, how much are we going to fill out the textbook? So we had already like touched on this a little bit in our conversation before the talk started, where you can just put the questions in your homework set in there and then leave all the coding blank and be like, your code goes here. But the way Data 8 is taught is somewhere in the middle, where you're like, here's how we're going to do it for one variable. Now change and do it for another variable. Let's copy the code. Let's change the variable name. Let's do the graph again for a new variable. Sort of like an ABC step through is more how Data 8's working. I was talking, and I'll get to the end, about an econometrics professor who was basically handing people a piece of paper and saying, hand me the homework back in a Jupyter notebook. So like it's completely blank. Or you could just have like the first line, read in the data set, then you do the work from there. On the other hand, there's people who aren't going to learn to code while you're doing it. You could give them things completely filled out, and they're just going through, running the chunks of code, seeing the visualization. And this is how I teach a lot of the time, where the code's there, but I want them to explain to me what's going on. Like, read in the data set, analyze the variables, and then my question is like, you know, did we see a reduction in the health outcomes for children, you know, due to our intervention? So like, there's the graph that sees like the randomized controlled trial. I want you to be filling in your analysis in the notebook, not necessarily doing the coding. But they're seeing it as part of the experience. So this is important for us to think about, like how much is it important that we're teaching computer science, or how much is it we're just like exposing people to seeing statistics and asking them like critical thinking about statistics. And you know, there's room to be in many different places here. Really quickly, we have another set of courses called Data 8 Connectors. I'm teaching one right now. This is how I got involved in the whole thing. If anybody's interested in teaching a Data 8 connector in their field of interest, talk to me because we're recruiting people for this. There's an open posting on, you know, for lecturers for this. These classes are structured so that you're in the 1,500 person Data 8 class. That's just generally about data science and computational thinking. And then you could be in this 2-unit class about your area of domain. So I taught one about economic development, randomized controlled trials. Right now I'm teaching one about reproducibility. So it's sort of like an applied class where what you're learning in Data 8, you can sort of apply to a topic area. There's one in English right now. There's been ones on city planning, neuroscience, a whole bunch of different really interesting, really rich content. And so there's sort of like a seminar where like once a week you meet and do some sort of data science problem, and it's sort of getting the people in Data 8 some richer experience. Write me if you're interested. But what we're talking about here is what we call is modules. The idea is generally that somebody has an existing class that we're just going to plug these data science methodology into. I think these numbers are a little out of date, but it's been about 1,700 students in 50 different classes have had this experience so far. So I would say there's probably, Alex, what do you think? Like this semester, there's probably easily like 400 or 500 students in classes.
For the modules?
For modules overall?
Yeah,
maybe more. Yeah, I'd say 700 or something. Some of the classes are pretty big. But anyways, the list of classes: rhetoric, women's studies, ethnic studies, linguistics, cuneiform. I didn't even know there was classes in cuneiform, but there's a module in cuneiform. Psychology, sociology, economics, legal studies, demography, English, just all over the place. Really fun applications, really interesting, different ways people have adapted this, right? This, you know, we're really interested in playing with people outside of the EECS and statistics world. We also use this word modules, just another disambiguation thing, to call our team of students that work with developing the materials. There's a website that you can go to that has some example ones if you want to just like stick your fingers in and play with them. That has like descriptions of some of the key, some of the, you know, more interesting ones. Just this is sort of like the website version of my talk. You can go to data.berkeley.edu and find it, or it's if you go to GitHub DS modules, there'll be a link for it there. And that will overlap with some of the ones I'm going to talk about right now. So again, this is going to GitHub. GitHub is this place that's, again, this file server for open source software development where all of our stuff is. It's funny, these are the ones from last summer. I must have taken this screenshot last summer. So GitHub is like, whatever's the most recent thing is going to end at the top. So this isn't the most recent what's at the top. But anyways, this is where your project would be. This is where you could browse other people's projects. Feel free to go visit and dig in. GitHub.com DS modules, there's the URL. So, and you can look at the Ted Miguel one, maybe not the Ethan Ligon one.
Why not?
I think, well, sometimes professors want things to be on their own GitHub.
Oh, you can have your own GitHub?
Oh, see? I know. You can have your own GitHub. We like to have things here, so I will probably at the end ask Professor Ligon if I can put a copy here, even though they're his materials, just because it's becoming a repository for awesome materials generally. There's a whole thing in GitHub where you can fork things. So you can just be like,
So I have a question. I use a lot of proprietary data. Is there a problem?
potentially, but there's ways to deal with it.
Okay.
There are ways to deal with it. We would, generally prefer not to, because we like open source everything, and we like the idea like these materials can be used by other people. But if that's your thing and that's what you do, then we can do that. One of the ways that we do that is your data could already be on the data hub, right? I mean, you would still be like, every student's going to have a copy on their file server at the time they run it, but you probably have to do that anyways when you assign an assignment. Like, you can't.
I was thinking about replication of stuff, right? As long as someone can run their code on data that are proprietary just to see if the results are replicable.
Yeah.
That would be great, right? They don't have to really have access to those data, but they can run code and see if it replicates. That would be a big, you're asking me what would be good?
Yeah.
That would be a big thing in economics journals, because a lot of data cannot be posted because it's proprietary. But if I get
Super
requests-
duper. It's a huge issue that's probably way beyond the scope of this talk.
Okay.
But
I just wanted
like,
to get
certainly,
that.
did you want to say something?
Well, I'd be interested in talking afterwards because we're exploring that in the context of proprietary data, but using the same infrastructure
Yeah.
for research,
Yeah.
also as well as sensitive data.
Yeah.
But I'm being bombarded with requests to replicate other people's papers because I'm the data curator.
Yeah.
Let's talk more afterwards.
Yeah. We're super interested. So there are ways that your data set could be somewhere like in a access controlled part of the Jupyter Hub server, but people could pull it, run analysis.
Aaron?
Yeah.
Aaron at the D Lab.
Aaron?
Coolidge. Culich. Yeah, so this is technically possible, for sure. Where am I going? Oh, American Cultures classes. So we've had a really awesome success working with these American Cultures classes. Every undergrad at UC Berkeley has to take a class in American Cultures. These classes are pretty big. Sometimes the enrollments are like 200 to 300 people. When people sign up for an American Cultures class, they're not signing up for a class that has computing in it. There are many people at UC Berkeley who have spent their lives fleeing from computing and doing whatever math they had to do to get into UC Berkeley and then moving away from that, right? We're still interested in those people. We're still interested that, like, those people don't need to be CS majors, but they're living in a world where it would be awesome for them to have like some ability to use these tools and some ability to not be afraid of like the statistics that they're going to see in doing their work. So we have these simple lessons that are for people that have basically, the way Data 8 is taught, right? So importantly, going back to Data 8, and a starting point of Data 8 is you only need the math from high school to take Data 8. You don't need any calculus or linear algebra to take Data 8. So we're also starting from that point of like, let's take a completely naive population. We know they're in UC Berkeley, but let's just take that level of math as like the basic and no programming experience and sort of walk them through some key steps. The way these have been worked in the past is like the data science student themselves come into the American Cultures class and teach that lab section or teach that lecture. We're hoping to evolve that a little bit because that's like not scalable, right? So we're teaching, there's one American Cultures class this year where the grad students came to the grad student orientation and hopefully they learned the tool so they're going to be able to deploy it in their sections. So both things are possible. It's like our belief, and we're really exciting, like if Jupyter Notebooks can succeed in this setting, it means that we're making data science accessible. So I'll talk about that in my next talk in a couple weeks. That's about accessibility, but I'll just highlight like why we're excited about these is like using them with somebody who's not thinking they were going to use data science in their class. I have Carla, who's here. She's a student who was in an American Cultures class and got the bug. You want to come up and talk a little bit?
Hello, everyone. I'm Carla. I actually right now also work in curriculum development. I actually came to this by taking this class. Well, the goal of this class was to, this project in particular, was to look at a research that was done in Chicago neighborhoods and apply it to Bay Area. So it was composed of like two parts. The first part was to do some field work and get the sheet that you see right there and actually translate it in a Google sheet. And then someone who was doing the curriculum development will put everything together in a data table and then hand it back to us. The second part of the project was to actually do some data analysis. So like he mentioned, there's different parts of the curriculum, of the development that you can do. A lot of it was like completely filled out for us, for us to just like remember, I guess, well, like linear regression and things like that. And then the second part was for us to actually do some analysis. And it was something super empowering because I never thought I would be doing this in this class. And it was also like very fun because I was able to like contribute to like this new like data set and actually see how like not only I could do like analysis, but literally everyone else in the class. I am doing like applied math and political economy, so I was acquainted with some of the tools that we were using, but I was also seeing how people who never, like he said, been escaping from like doing analysis, computing, and math, like were actually able to also participate on this class. So, yeah.
Cool. Thank you. Students will come up after, so you can ask the students questions. So just really quickly, this is like a paper-based form. That was a famous one from a famous sociological study, and they could read in the literature about the study about neighborhoods in Chicago, how many cigarette butts and broken cars in the neighborhood. They go out on the bus line to some other parts of Berkeley where students might not normally go, and they go and visit a block and fill out the form, but in a data way. And then this is a really nice one where like the student has like taken a picture and submitted a comment. And so students really like this, where they see sort of like the information they gathered, but in the data set. And there's like a really good learning there where students see that. There's another part, as she said, where they did the data analysis, where then they take information from the census and they sort of overlay the information on the census on the information that they're gathering by these blocks that they're visiting. So there's also like looking at the data set and like, you know, how much does the data set, the variables that are available in the data set that might describe a neighborhood corresponding to what the students like actually observing the neighborhood. So there's like multiple aspects that are really nice for learning here. Another one that we had was Psychology 167, Stigma and Prejudice. A lot of social justice issues, obviously, in all the American cultures classes. This was like a simple set of notebooks where they learned the very basic simple elements of correlation and regression. They learned just about notebooks in general, then correlation and regression, and then finally they gave them a set of data sets and said, do your term project. And they had, this is just like weirdly a screenshot of GitHub, but you can look at these data sets that were like hate crimes. So there's some of them were like about race, implicit bias on race or hate crimes, and then outcomes that were about health outcomes, like heart attack mortality. So students could pick some one of like these racial bias variables and some outcome variables on health. These were organized by county, so just like, you know, if you live in an area with more racism, does it affect the health of that population? So not a lot of things are significant, but it's like giving students like a run through of what it would be like to test a hypothesis and then saying like, here, you take the data set, try testing a hypothesis. And they've run this a couple times, and you know, a lot of, it's not, I won't say that like every student is like, this is the best thing ever, you know, but it's challenging a bunch of students to like, you know, do something a little bit harder. The professor really likes it. We have 3 more American cultures classes this semester. So there's an environmental justice one. This one has pollution versus health outcomes and race. So looking at multiple variables. There's this engaged engineering one. Carla worked on the last 2 of these. So last semester, Carla was working on developing the notebooks for the engaged engineering one. I think this is across countries, and it's like carbon emissions versus like human development index, so like wealth of the country versus carbon emissions, examining those things. And then Ethnic Studies 21, this is looking at overcrowding in prisons, and there was an important part in the Supreme Court, and then in California politics, where they're trying to reduce overcrowding in prisons, and this is like actually looking at the population of prisons. So this is a class where like they're digging in a lot to the social justice, and there's like a formerly incarcerated person who's one of the TAs for the class. So they're digging into the issues in a lot of other ways, but then they have like a data science way to like illustrate things at the end. And these are all this semester. I don't have the outcomes yet because they're just being deployed like around now or in a couple weeks. Another one that I have that's exciting, and I have Alex here who can come up in a sec, but I'll just give a little intro, is our first lab class. So UC Berkeley is full of lab classes where people have to fill out notebooks and do a little analysis in a notebook. This one was a physiology class, 400 students, like a classic undergrad lab class, probably pre-med students. So what's the existing thing? The existing thing, it's like a little bound-up reader that you buy at the copy shop. It's a Word file that says how to do the lab experiment. And then there's an Excel file where, like, when you're done, you, like, enter the data that you got into an Excel file. And then maybe you make a little graph and you pasted that graph into something, or you put it in your lab book somehow. But maybe I can get Alex to come up. And there's a couple nice slides that sort of walk through an actual procedure.
So hello everyone, my name is Alex Nakagawa. I'm currently a junior studying data science and industrial engineering operations research. So a little background on the MCB 32 class that I was the curriculum team lead on. Specifically, we had a group of 5 students who were tasked to essentially take all of the Word documents, all of the lab instructions that were kind of convoluted, and put them into a notebook format that would be easier for students to interact with, essentially. And the way they interacted with it, mostly, firstly, with the first few labs, were to explain very basic data science methods. And when I say data science methods, I mean using the Data 8 package that's actually developed and put onto Data Hub servers, and then to be able to create visualizations with them with the sensor data that they were collecting during the class. So development for this specific module was a little bit challenging based on the fact that we didn't have the data to begin with, because they would be collecting it during class. Nice. So the biggest challenge here was to kind of take these instructions that we have been given, and then kind of give it put it in Python, and then be able to explain it clearly. So as an example, in one of the labs that they had done, they were doing EMG stuff specifically on their forearms, and the muscle force electrode placements all done here. And then to collect that data, they are still using a third-party source software to kind of collect that data and be able to export it into some kind of Excel file. And then from that Excel file, they were supposed to create that graph either within Excel, or they were. I apparently heard from the professor in previous years they were to actually sketch the actual graph on paper, which seems kind of ridiculous, I guess, in a sense, which is why they had come with this problem statement for us. So this is just an example of what the bottom of the worksheets would look like, and they were to essentially kind of fill this out by hand and then put it into Excel from this table. And it was just a very drawn out process that we definitely felt like could be streamlined through the Jupyter Notebook environments. And so this is very quick. What essentially would come out of a lot of the data that they had exported is a very simple graphic using the matplotlib library in Python inside of a Jupyter Notebook. And it can very clearly see some of the relationships that from the data that they had collected just 20, 30 minutes prior. And the week before, this is the first lab class that many MCB students take, even besides, I guess, biology 1A. So a lot for them, this was very new, a new topic in essence. So I was really proud to be able to, and felt very privileged to be able to work on a project like this. And I could see a lot of the ways that you can port this over into different academic fields in a way. So yeah.
And you could see like that diagram's like not that far off from a journal diagram, right? Like just a little bit of formatting and it could be in a journal article.
Mm-hmm.
And so it's empowering for the students.
Yeah, definitely. And this definitely working on this project in particular really opened my eyes to what the different impact that we could have as undergraduates on campus in particular. So I'm actually am now working specifically with Professor Alan Hubbard in the public health, like School of Public Health currently, to work on a class called Public Health 241, which is like epidemiology and like statistical analysis of categorical variables. So yeah, love to do this kind of work and be able to have this kind of impact. Hi, question, yeah.
Why don't you say a bit more about the extent of like commitment to be in your role, and at what scale are we having students doing this kind of curriculum development, module support?
Right. So I guess it varies depending on whichever module that we're working on. For this particular, the MCB 32 project in particular, what the commitment essentially looked like was to be able to manage this team of 5 other undergraduate students who had a wide range of skills, like ranging from like just had taken data 8 to done data visualization and like industry practices. So like that was the first part of the commitment. Second being also working like collaboratively with the professor to make sure that we got things done in time, like a week before, so that they had a chance, like all the GSIs of the class had a chance to talk it over and see if like what we had developed was like sufficient enough for that specific lab. So every lab was different also as well. So that's why we had one person from our team focus on one lab, I think, which made sense in essence, because every lab was, it could vary from like doing a data visualization as simple as like a line graph to having like the entire class collaborate all of their data sources. So one of the labs actually talked about importing from multiple sources and then creating it into one giant table. That was just one like section of the lab essentially that they had gone over. And yeah, I guess.
So sorry if I missed it, but are you getting units for what you're doing?
Yes, that's right. Yeah. So I joined the Division of Data Sciences as a curriculum developer last summer, and I worked in an engineering or energy resources like new class that they had developed in that. And then I moved on to become one of the team leads that would be managing the team specifically. One for MCB, one for global studies, gender women studies. Sorry, another one also as well in. But no, that's it. Yeah.
Started out for units. Now he's getting paid.
Yeah.
But paid by you, not by the departments that want to do this, right?
That's correct.
Yeah.
Otherwise, our department would just like, oh.
Not even try.
Yeah. Yeah.
Yeah.
Mm-hmm.
Cool.
How long does a unit take to develop?
Sorry?
How long does a unit take to develop from the time
Oh.
a faculty member comes in with a problem statement to having something in the classroom?
That's a great question, and you can chime in on this as well. I believe that the Professor Robin Ball came up with this over the summer.
She came to the summer workshop.
Yeah. Mm-hmm.
So we met with her over the summer. We like to have like a semester out. Like, right now we're developing a whole bunch of things that are being deployed in this semester, and that's stressful. We would really love to develop things for, like over summer or for the next semester, but it's tough. I would say like 4 to 6 weeks is a common, like once students are like digging in and like actually working on something. I mean, the ballpark answer was, I don't know, he was asking the question, but student volunteers are like 5 or 6 hours a week, and they're going to put like 20 to 40 hours into like a notebook. I mean, but it totally depends on the project.
Right. And this was one of the projects that was being deployed continuously. So this lab was basically finished 2 weeks before it would be deployed, and then the professor and the GSIs had 1 week to look it over before it was like officially deployed in the lab. Yeah.
But like I'll say one at the end where it was like, there's the econ professor who had been handing out a PDF, and I got like the LaTeX version of that, and I made it in like half an hour and sent it to them, and they sent it out, and it was just like something I did that afternoon. You know what I mean? So this is like a really involved one.
Right.
Speaking of involved, let me go one more. Thank you.
Yeah.
You can come back up. That was awesome. So this question of like, what about lab notebooks? So if any of you know people that I can go talk to in bio or chem or maybe the physics department.
We would love to talk.
Do you see it says Physics 8A right there?
We would love to talk.
Yeah, I think it would be cool. And I think we're getting more tools. So apparently we're going to be able to enter the data right into the notebook and then be graphing it right away. We've made some headway. I have this great idea of like, couldn't all the students enter their own lab notebooks and then that generate the class lab notebook? So we're like working on that. So we're working on making this better. Yeah, so let's just go quickly to legal studies because we're running out of time. We have Annika here who can talk about it. This is a class that's just another example of like something really intensive. Annika was the grad student. Jonathan Marshall was the professor. Jonathan Marshall came to the summer course, got this like, oh, there's so many cool things happening in law, like applications of amazing things in social science. But Annika was like the student who like was able to like make an incredible number. So this is like what we would call a data-enabled course. The course got redone on the basis of teaching so many different techniques. And they went through like machine learning and text analysis. And so this is basically a different vision where it's not like take a class and add a little sprinkle in here like we were talking about before. This is like build a class around this and like empower students to become data science over the course of a semester. You want to come up? And basically covered a whole bunch of different topics.
Yeah, so I'll get into that real quick. I'll try to be short so I can leave room for questions and whatnot. But we basically had 4, I would say, sets of kind of tools and skills that we wanted the students to develop. One was kind of basic social science, so a lot of that was reviewed from Data 8, plotting descriptive statistics, getting intuition for what an average is, why it matters. Really, my goal there was to teach the students not formal mathematical theory about statistics, but rather have them understand sort of the shape of data, how to visualize it, how to think about it in a social science context. Then we moved to mapping. So you saw a little bit of that in the sociology module. But show them the kind of basic tools for mapping in Python, integrating that with social science data sets, thinking about, could I model voter turnout? Can I model crime? Can I just look at this on a map and start to think about how this interacts, or how this interacts with society? And again, the tool is paired with lectures and discussions in class to encourage them to think about, hey, is crime spatially distributed the same everywhere in Berkeley, in San Francisco, anywhere you would think of? And then we start having them think, why do neighborhoods matter? Why do particular streets matter? Why does it matter that you see a lot of crime over here? How would that affect police behavior? Really try to integrate these tools with the social scientific thinking, start to build up their intuition. Then we move into machine learning, and again, we do a little bit of the math to kind of have it out there for the students who want to learn more about it, but we never test them on specific mathematical concepts. We never have them write a proof, nothing like that. Rather, we introduce them to regression, we introduce them to machine learning, and start getting them to think about prediction. So one example is, and this is called data prediction in law, one example is thinking through algorithms that decide whether or not a particular defendant should be paroled or not. We read a lot of things about how judges and the criminal justice system are using these sorts of systems. And it's one thing to sort of think about it, critique it, whatnot. We try to have them actually think about, how would you model this? How would you do this in Python? And this is useful for a couple of different reasons. One, we get a lot of EECs, data science, statistics, people from all over the kind of technical side of things, who come in and they start to challenge their own beliefs about what it means to create a fair algorithm or an unbiased algorithm. They start to get a real intuition for what it means to integrate their own social context into an algorithm. I would wager that you could ask most kind of technically trained people, oh, how would you make a fair algorithm? Most would say, oh, as long as I don't have race in there, that's okay. We go through and we show them how you might still recover race inadvertently. You might be very well-meaning. How you might still accidentally use race in your algorithmic decision-making. And we have the students actually grapple with that with code and with literature that they read. Then the final thing that we cover is text analysis. So this was interesting for us because coming from law, there's just tons and tons of text. Congressional hearings, legislation, court decisions. just reams of text that we could possibly use. So we use one source called the Old Bailey, which was England's criminal court, still is, but England's criminal court from 1600 until 1900. So it also has this cool kind of historical context. And we basically teach them how can you download text from the internet that's stored in some kind of database, an API, something like that, download that, process it, and then think about using it in data science modeling techniques. So we, for example, in a problem set, have them download that text and then predict what a defendant's sentence was, or predict what the verdict was on a particular case. And this is from cases from like the 1600s and 1700s. It's also kind of cool for illustrating the evolution of the English language over that time. So this is a lot. It's a ton of material in one semester. 4-unit course. We have 2 2-hour meetings each week. It's just a ton of material that is not too deep. You could probably take one course on any given topic, but it is pretty difficult. It is a lot of advanced topics all at once, but still tries to be accessible. So this is what our GitHub looks like, just to give you a kind of example, and we're actually currently in the process of building this out and making it more public-facing. I have my own copy on my own GitHub repo, with the idea being that maybe other legal studies or law school departments who are interested in teaching a data-enabled law course might look at this and say, hey, there are all of these labs available that we can integrate into our own kind of work. And just to give you a flavor of what it looks like in a particular lab, so this is our intro to text analysis lab, where as you can see, we have a bunch of rows here. So this is the UN General Assembly debates that we used in this particular case. So each one of these basically is a huge statement made by a UN delegate. We teach the students how to import this, process that text, put it into something sensible, and eventually do something like this. So this is a different data set that uses Stack Exchange questions. Basically process their text and start to do things like predict what category did that text fall into. So Stack Exchange, for those of you who don't know, it's like Quora or any other, or Reddit or something like this. You ask a question and get help on your code or any kind of software issue that you might have. So we have students actually take the raw text of some of these questions and predict what category does it fall under, what tags does it have associated with it, just based on that text. And then this gets ported over to legal context once we start doing the problem sets, the exams, things like that. But as you can see, basically we want to give them the familiarity and the confidence to think that anything could be data. It could be geographic, it could be text, it could be anything, but we want them to have the confidence to say, we can go find our own data set, we can think through a social science problem, really frame it the right way, and then develop our own tools, develop our own code to actually go about answering that. I would say insights from developing this and teaching it, it takes a lot of people and a lot of hours. So I would say we have something on the order of like 35 or 40 labs just for this class over the course of the semester. So some of these I developed myself, but the vast majority of them came from the modules team, and a huge amount of effort that they put in. It was super professionally done. We couldn't have done this without them. They go through and painstakingly make sure that everything is accessible. It's explained in a really neat way to the students so that they're actively learning as they're engaging with these lab notebooks, and not just kind of, oh, yeah, go ahead.
40 labs in 14 weeks.
Something like that. So
something here.
Twice.
3 a week.
So it's twice a week, plus we have some homework ones that we have them do, in problem sets that we integrate as well. So yeah, sorry. In terms of materials, I would say it's something like 28 or 30 over the course of the semester in class, and then we have 6 problem sets, a final investigation, a final project, and a final exam. So between all of that, it's something like 35 or 40 different notebooks that we have available. Sorry, misspoke there. Other questions?
Alex, do you know what, or Carla, do you know what Data 8, I mean, so Data 8's got to be on a similar scale, because Data 8 has like labs, it has instructional notebooks, it has homeworks, it has projects. It's got to be in the like 40 or 50 notebooks or something. It's a lot. Yeah.
It's like one, I would say like one lab per week, and then just sometime, well, every lecture they have, of course, have
something,
the,
yeah.
One
like
that goes with the lecture.
stuff too, yeah.
Yeah.
So it could be even more than 50, yeah.
Yeah. So I'll go ahead.
I just don't understand what this matrix is.
Oh, sure, yeah.
So I understood that you pulled in text from a UN speech. So now what do we see?
Sorry, yeah. So this is a different data set. So this comes from Stack Exchange, where the question will have a particular label associated with it. So you might be asking a question about Python, or it might be about XMLs, or it could be about developing for Android. So what this matrix shows basically is you have a predicted label and a true label. So say where it intersects Python and Python, what that's saying is the student developed an algorithm that tried to predict, based on the text that they saw, what tag would be associated with that text. So this 90 basically says 90 times the algorithm predicted Python, and in fact, it actually was Python. But there were 12 times where it predicted Python, but actually the question was about XML. So this is a really common tool used to visualize classification error, where it basically says, let's think about how many times a class was predicted relative to how many times it really was that thing. So it's called a confusion matrix. And it's a really cool tool for basically visualizing these sorts of classification problems. And again, the students are able to do this. They use it in their problem set. It's really neat that they're able to kind of visualize that sort of thing.
A classic machine learning thing is you have a data set where you know what a bunch of the answers are, and you can divide that up and use it as for training the algorithm to do things, and then you can check how often the algorithm did a good job. And this is like categorizing, like how did your training set perform? How did your algorithm do on the training set? And this is like, oh, could I provide a statistic? Or this is like visual, like, oh, the better the color, the better my algorithm's doing. So we jumped ahead to just sort of be like, here's a really complex machine learning classification output.
Was that a hand?
Yeah, I wasn't convinced about how to incorporate some of this into my introduction to cognitive science class with two extra students. And until you presented this piece, I want to talk to you maybe after.
Oh, sure, yeah, I have time afterwards. Yeah, flag me down.
I'm convinced.
Sure.
Nice.
Absolutely.
I would say that the big insight, the most rewarding thing for me in teaching this class is we really did a good job successfully integrating the legal and ethical side of things with the actual sort of practice of data science. That was really, really useful. It really made the sort of domain aspect of data science make sense to me and it was really attractive for the students as well. A lot of them coming from EECS or statistics and some kind of just starting off as data science majors. As they're trying to figure out, okay, I'm piecing together a little bit of computer science, a little bit of statistics, as they're trying to figure out what it actually means to have a domain focus, so tightly integrating it together and making it challenging for them was really useful. Yeah.
Do you require Data Science 8 as a prereq for this class?
Yes, so now we do. So when we first offered it, we didn't, but did recommend that if they didn't have it, they should kind of check out coding, make sure they're sort of comfortable. Yeah.
Because our major doesn't require Data Science 8, and that makes it difficult to know how to do it.
So what we did, so legal studies had a stat requirement already in place, and I think it was stat 20 maybe that filled it.
That's what most departments are doing, is like putting data 8 instead of stat 20.
Yeah.
Yeah.
So I have a couple of questions. One is, this is an undergraduate course.
That's right, yeah.
Taught at the graduate level.
Well, yeah, I'm wondering about law students. I mean, is studying penetration in professional schools?
I don't think so. I think there are discussions right now in the law school about how to think about integrating something like this. The challenge is that, like, to integrate any kind of coding, anything into the law school curriculum, you need to go to the American Bar Association, and there's like a sort of back and forth there. There's a question of how many sort of like skills-based courses they'll sort of allow in curriculum on top of the stuff that kind of exists already. So it's a little harder at the law school level for those reasons. But we've had a few actually come in and sit in on our legal studies course just because of interest in thinking about how to integrate it into their own sort of practice and thinking. So there's a little bit of a change. I know, and we could talk more after if you're interested.
The answer is more interesting than
Oh, yeah, sure, yeah.
The other question was, how long do you guys predict before Data 8 is a prerequisite for a faculty appointment here?
Nice. Well, that's why we teach it in the summer. You come, we'll teach it to you in 3 days.
Yeah, right.
I would say from a grad student's perspective, I haven't explicitly had Data 8 per se, but I've probably pieced together basically all of it. Yeah, something like it. And I would say that it is becoming more and more kind of standard for anyone in the social sciences anyway who's thinking about doing sort of quantitative work to have that kind of background. So I imagine like the people that we're thinking about hiring as juniors in the next few years will be very well equipped to start doing something like this, even if they haven't taught in Python. I think could very quickly sort of catch up in some ways. Yeah.
I'm a grad student in the Spanish department and I had no background at all in programming, and they offer Data 8 online for free. In case you want to start to familiarize yourself with the content. You can access all the 3 different modules online completely for free. And then if you decide to enroll, I think it's $300, and they give you like a
certificate.
Oh, that's fantastic.
And you can parse the 3 different modules to your convenience. So you can, it's 5 weeks every module, and you can do now the first one. You process everything that you learned there. Next year you do the second one, and then next year you do the third one. So if you want to plan with lots of time to incorporate this into your professional profile, you can do this. Not to have to do everything in one semester. Like you can.
What department did you say you're in?
Spanish.
So what fraction of your colleagues have done this?
No one. I'm the first one.
Okay.
But it's possible. I've been doing this since August, and I started with Data 8 in January, like enrolling. But before that, I had already like a first look to see, okay, can I do this or not?
The very last piece of pedagogical advice I'll give, because I know we're probably short on time, what's worked really well for us in terms of teaching this stuff, the labs, we have a student notebook that does sort of what you were mentioning, where it'll teach some kind of concept, have them fill in a little bit, but have some filled out to sort of help them out. We make the solution notebook available for the in-class labs side by side, so the students could look at it. If they're struggling, they could take a look. We have them work together. I walk around. We now have connector assistants who also walk around the class to help figure all of that, to help them within the class itself. And we don't grade any of that. We don't look at that. And for the most part, it's actually worked. Students will do it in class. It's like in Data 8. They're actually interested in doing that bit. So we don't grade any of that. And instead, in the problem sets, we take the concepts from the labs, make them slightly harder, make them in a way where you encourage students to go look up some of the answers online, figure out how to solve some coding challenges. Again, they work together a lot on the problem sets outside of the class, and that's where a lot of the real learning happens. They kind of figure out how to work through an original problem by themselves, and I think that's what maybe makes it advanced in some ways, whereas the previous courses, a lot of it, you provide a lot of the data, you try to simplify things as much as possible. The jump in difficulty comes from these problem sets now, where they have to sort of work through novel problems that we didn't explicitly cover in class, but I found that works really well. We basically make the classroom as friendly and inclusive as possible to make sure that they have as much support there. Then when they go home, they can start to struggle through some of the harder problems, come to office hours, of course, talk to us, all of that. But that model has worked really well for us. I'll just finish with that.
Nice. I should probably wrap up. Yeah, one other thing that I have is you can also make the notebooks interactive with like sliders and click. This is like if you don't want people to program at all. So I had one, teaching econ, I had a simple one where there was like sliders and you could change the parameters on the graph. This is the most classic Econ 1 thing that you could imagine, that like everybody has to learn to do this with pencil in Econ 1. It's like resolving the whole time, so it will give you the solution, and then you have to like, like this is like a midterm question, like you have to like do the areas of those triangles in Econ 1 or Econ 100, and so like this just resolves them. So that thing of like nobody's changing anything in the code, but you can actually make it so people are like changing parameters with a slider or a click or a drop down or something. So just like another pedagogical way to think about things. I think Aniket has a couple of interactive ones where you're like, how many parameters are going to put in the algorithm? Or there's also ones where you're like a 3D visualization where you're like, I'm going to turn the visualization and look for the separation between the whatever I'm trying to classify. 2 econ classes really quickly. It's really important. We can do everything in R on Data Hub. This is a totally stealthy secret thing that nobody knows, but it works killer. We have a class of the iSchool running and Econ 172 running right now. I'm not going to get super into it, but This is an R Markdown document that makes a very beautiful homework. Like, this is the homework that students are turning in. Again, like, there's the code, there's some LaTeX equation. It's really beautifully formatted, so it like can make for really elegant homework. This is where like a grad student put some time in to make this look beautiful. And then here's the one. If you guys weren't here when I was coming in, before we were starting. So this is the one that I did in half an hour. This is the professor was getting students to do their homework in Python, but he was handing them a piece of paper and telling them to hand back in their homework done in Python. So he was like 21st century tool, but a 20th century approach to homework. And I was like, wouldn't it be better to use this really cool thing, Data Hub, that we have? He didn't ever come to a meeting. He didn't meet me in person. But anyways, I was like, I got this tech file, and I just made up the Jupyter notebook in a half an hour that corresponded to his file. It just reads in the data set, explains what the variables are, and then is a blank cell that's like, do homework, do problem 1, right? So like, I didn't do any of this complicated coding it up. I just took what he had already done for his homework. But now the students are getting it. They're computing on the cloud. The amount of time and energy that this has saved his GSI in dealing with things is huge, right? For the GSI to be like, install the right package, make sure that it runs right, make sure your data set's in the right place, make sure it's read in the right way. Like, this is a huge headache for the GSI that this professor wasn't internalizing, right? And you're like, okay, this is like this whole workflow that we've made to make your life easier. It exists. So I just wanted to have this as an illustrative example of like, there's a whole bunch of advantages for students. Like, it's very pro-student, but there's a whole bunch of like classroom management things that are really useful. So anyways, I want to wrap up. If you have more questions for the students, but we're here so that you'll join us. Come visit us on the web and see these examples, and you can play with them, or you can look to them, or a lot of them will have interact links you can go to. Email me. I'll come to your office and meet with you and pitch it to you and see what you want to work on. There's a workshop in 2 weeks in this room that's about accessibility. That the pitch is like it's good for all students. But I'll actually run through some of the steps, and if you bring a laptop, we'll be like, all right, let's try and deploy something on B courses. And sign up for the summer workshop in this room. We'll get your class going. We'll get you familiar with Data 8 if you want to come to the summer workshop. And a grad student one on the Friday of that week. So lots of places to engage. Totally email me. I'm happy to meet with you in person. That's my job. Thanks for coming. If you have more questions for the students.
Eric, is this workshop very different from a couple of years ago? The June 3rd.
You came to it before.
I came to it when Sarah.
It's similar, yeah. It won't be that different. Hi.
Hi, I'm sorry.
Eric, you look really familiar.
Uh,
I was reading your emails on the TeachNet.
Yeah, I've been
Public policy.
about
So, public policy 240.
240. I don't teach it, but yeah, we have it. We do it.
So I'm convinced that we should.
Oh, tell me about it.
We should do this for 240.
Of course.
And
but actually, I want you to do something else for me.
What's that?
For me.
Oh, for you? What's your class?
So first of all, where do I go to find like all the links that have gone by on your slides and stuff?
So I'll send you the slideshow directly,
right,
or you can go to databerkeley.edu. I have your email.
You do? Okay, just send me something.
Yep.
Okay, so halfway through this, yes, I know exactly what I want from these guys. I teach a course on arts and cultural policy, and I've been noodling about a hypothesis for several years. I can give a sort of database argument to back it up, that the information content of popular art, music, and plastic arts has been going down over the last 3 decades. And there's some Spanish economists who actually looked at popular music files and calculated rhythmic variation, timbre, number of different instruments, and it supports this.
Wow.
So I want you guys to make me a tool which I can send my students out to say,
yeah,
assess the information content in the technical sense the entropy
Yeah.
of a work of art, painting, right? And so my idea was I'm going to get a picture off the web and then I'm going to convert it to an image file at some known density.
Yeah.
And I'm going to look at the size of that file, and that's that's the size, that's the information.
Got it.
I don't know.
I like it.
Okay. And they should, this is a cool excuse to